Okay, good evening, everyone. Welcome to O-level physics lesson, our last lesson on practical electricity. My name is Mr. Chu. Today is Tuesday, 6th of July. Okay, a quick recap of what you have learned before this lesson. You need to know two formula. Okay, before this lesson, you need to know two formula. V equal to Ri, as well as energy equal to power times time. Okay, so these are the two prior formula that all of you need to know. Okay, the one formula that you're going to learn in this topic, just one formula. You only need to know one formula, and the formula is power equal to VI. Okay, that is the only formula that you need to know for this topic. Okay, power equal to VI. And if we substitute V equal to Ri, I'll get Ri squared. Okay, as well as we can get V squared over R. Am I right to say that? Okay, so all the green formula can be derived from the red and the blue formula. Okay, then the second one here, E is equal to PT. P is VI, so you can just write down VIT. Okay, you can derive from there. And then the rest of the item, you just follow on top, add a T behind. Okay, add a T behind and you get the answer. Understand? Okay, so these are all the 6 formulas that you need to know. The only new one is the blue one. The 2 red one, you have already learned that prior to this topic. Okay, so let me start with a question. Okay, look at question number 10. Okay, just look at question 10. Do question number A first. Okay, you all may begin. Do question A. It is a 3-mark question. Okay, all of you do that now. Okay, start doing question A. Xiaoxing, your answer is correct, but can you put the significant figure thing at the back? Okay, can you copy and paste and improve your answer? Okay, Yuting, well done. Xiaoxing, well done. Okay, then for both Yuting and Xiaoxing, your exact answer leave it in the working, because in your subsequent working, you use the exact answer, not the round off answer. Is that clear? Because if you keep on using the round off answer, your final answer will be very far off, because it's all round off. So every single time you round off. How Ray, your answer is too accurate already. So what can you do to make your answer more appropriate? Okay, I want you to write down the round off. You round off to how many things? Okay, so what you can do here is you can write down the total current. Okay, you can write down here. This is 584, and this is 34. Okay, my question now is this. My first current is 450. Second current is 34. When we add them together, do we look at significant figure or do we look at decimal place? Are you you all know what I'm trying to say? Okay, I give another example. Okay, this is very important in your practical. If I got two lengths, I try to measure the height of this guy. Okay, plus the height of the shoe. Okay, the height of the guy, you use a measuring tape. You measure 1.824 meters. Is that clear? Then your shoe, you use a vernier caliper. Okay, you may be able to get a 3.44 cm. Is that clear? So now, what is the total height of this guy? Okay, let me change all to cm. Okay, if I change all to cm, this will be 182.4 cm. Okay, so I want to add these two together. How do I do? What do I do? You must remember that your final answer can never be more accurate than these two answers. So when I add them up, this is to 1 decimal place. This is to 2 decimal place. Okay, so if I were to add, okay, if I use a calculator, I should get 185.84. But the thing is this, your measuring tape has an error that is not accurate up. Okay, it's only accurate up to 1 decimal place. So your this 182.4 can be 182.41. Am I right? It can be also 182.42 or 43 or even 182.38. Because your measuring tape is not so precise, therefore it only gives you to 1 decimal place. So the last two figure here, this is the accurate one. The next one is not accurate. Can you leave your final answer with 2 decimal place? You understand what I'm saying? Is this useful to you? So when you add or subtract, you look at the decimal place. Are you clear about this? So in your practical, you need to be very clear because this will be tested. So this case is 1 decimal place. This is 2 decimal place. Because you add or subtract, you look at the lowest decimal place. Okay, so your final answer will be 185.4 cm. You write down 1 decimal place. Are you clear about this? I try to explain to you the logic behind it so that there's no need for you to memorize. Does it make sense to you? But when you do your working, you use this to do the working. Okay, but why is this 4 not accurate? It's because for your measuring tape, the actual height could be 182.41, for example. But because your measuring tape is not so precise, you cannot see the 1 behind. Because if the actual height of the guy is 182.41, your final height will be 185.85. Am I right to say that? Just because your tape is not so accurate, you cannot give the second decimal place. Because your tape did not give you the second decimal place. Did I make myself clear? Did I make it very easy to understand? So all your practical, if you were to add or subtract, you look at DP. Okay, so in this case, it's 450. We do not know is it a full number or is it the 2 decimal place. We just use 484 lah. Doesn't matter. All right. Now, you're going to find the total power. How to do this? Total power when in full use, power is equal to VI. Your V in this case is 230. Can you see here? 230, 230. So it's 230 multiplied by the total current, which is 484. Okay, sorry. The answer here is milliampere. So if it's in ampere, is 0.484 ampere. So you multiply by 0.484. Okay, in your working, write down the full answer. In this case, will be 111.32. But because this one could be in two significant figure. This addition, this is in two significant figure. Your final value could be 3. You leave your answer in two significant figure. Is that clear? Okay, for this question, if you leave to 3, I think it's also okay. Okay, why? Because in these two working here, this is 3 and this is 3. This could be 3 also. So if your answer is 111 watt, you put 3 single figure, is also okay. Okay, for those who just cannot remember, then you put everything to 3 single figure, like in your mathematics. But there's a chance that you might get wrong. Okay, but if you just cannot remember anything, just leave everything to 3SF. Is that clear? Okay, so that's the first question. Now we go to the next question. Okay, calculate the amount of energy supplied in 1 week by the main supply to the television when in standby mode. Okay, let me give you all some data. V is equal to 230. In standby mode, the current is 34 milliampere. Okay, you want me to begin? Okay, the questions here says leave your answer in joules. So all of you do that now. Any one of you that's stuck, okay, please tell me. And where is Ryan? If you are here, say hi. Okay, you're not here. That's why there's no hi. Ryan, since you are here, can you start doing the question? All the previous question, I did not even hear you. I didn't even see you. Okay, begin. Qiao Xing. your current is wrong. Okay, Chelsea, current is wrong. Try again. Yi Ting, you're correct. Well done. Okay, Chelsea, you got it now. Well done. And again, for Chelsea, can you write your actual answer in between? Okay, before you run off. How Ray, can you write down how you actually run off to how many significant figure? Okay, waiting for Ryan. Okay, Bei Kwan, are you there? Oscar incorrect. Bei Kwan, you're left with you. Okay, let me go through the question. Okay, you know that all of you know that energy is equal to power times time. Am I right to say that? So energy is equal to power times time. For this question, what is the power? Power is VIT. Okay, you should know this formula by now. What is the V here? V is 230 volt multiplied by I, which is 34 times 10 to the power minus 3. Then multiply by time. Time in this case is in second. So for 1 week got 7 days, got 24 hours, got 60 minutes, and then each minute of 60 seconds. Okay, so you do this, you'll get your answer in joule. Okay, so your big exact answer will be 4729536 joule. Okay, you look at this one, 7, 24, 60, and 60. This one is one single figure. So why do I not leave my final answer in one single figure? Okay, because the 7, 24, 60, and 60 are constant. Okay, so you don't need to bother about the significant figure of the constant. Okay, so all these constant you just ignore. You just need to take into account the significant figure of these two values. Okay, so the voltage is 230 volt. The current is 34 milliampere. This is 2 or 3 single figure. This is obviously 2 significant figure. So your final answer should be just 2 significant figure. So in this case, it will be 4.7 megajoule. You write down 2 significant figure. Is that clear? Oscar, can you do again? Ryan, can you do again? Bei Kwan, are you there? Oscar, 1 week is a constant. Okay, 1 week is a constant. How you get 3.9? Oscar, I don't understand what you mean. A is about asking what is the power if you on the TV. This question is about what is the energy when it's on standby mode. So you don't use the A answer for B1. Okay, everybody do. Okay, let me see what Oscar is asking me. You mean for this one? For A, they don't even ask about time. We just talk about calculate the power. 138 hours. Okay, but for this question, for part B1, the question is 1 week. Or you mean based on this? Based on this one, you use the 138 rather than the 1 week answer. Okay, hold on. Okay, Oscar made a very good highlighted a very good thing. Okay, so Oscar says that in the question, the student in 1 week use the TV for 30 hours and then stand by for 138. So what he's trying to tell me is that in this question, calculate the amount of energy supplied in 1 week by the main supply to the television when in standby mode. Okay, so what Oscar is saying is for this question, we don't look at the 1 week. Okay, we should look at the when in standby mode. Okay, very good, very good. Okay, if that is the case, we don't use this anymore. We use 138 instead. Okay, we use 138, then what is the answer? Okay, if you use 138, your answer will be 3884976. And your final answer will be 3.9 megajoule to 2 significant figure. Okay, based on what Oscar said, which is the better answer, the red or the blue? Let me read the question one more time. Okay, I read the question one more time. It seems to support the red answer. Calculate the amount of energy supplied in 1 week by the main supply to the television when in okay. I think both definition can be also true. Also depends on what is your definition. Okay, so based on Oscar definition, based on the question above, it should be 138 hours. Okay, if I were to take the 1 week literally, it'll be the red answer. So how do you actually how do you actually interpret the question? So this question, now that you all mentioned, is not a good question because it's up to many interpretation. Ryan, you understand now? Either the red or the blue answer. So can all of you do part 2 now? Okay, do part 2 based on either your red or your blue answer. Okay, begin. Okay, Yiting, you are using which answer? Okay, based on your red answer, your course is correct. Okay, Yiting, well done. How about the rest of you? Qiaoxing, why is your hold on, Xiaoxing are using, okay, wait. Oscar, I think your answer is okay. Well, why you got no working one? Okay, Chelsea, how do you get the 28512? How do you get 28512? Ryan, incorrect. Try again. You think your question is a general knowledge question, is it? Asking me why? Okay, you think that's a very good question. Can you share your question to everybody? Just type again and then let everybody see. Okay, the obviously you think question. Why do devices have a standby mode? If you want to save money, right, you shouldn't even standby, just switch off. So why do you need to spend a few cents to have your TV on standby mode? Anybody can try to answer, you think? Why do devices have a standby mode? Okay, for Chelsea, can you explain to me how you get 28512? That's my question for you. How you get your 28512? Anybody can answer me? Okay, answer you think. Why do devices have standby mode? Why do you need your device to be on standby? Can't you just switch on and switch off? Why do you need to standby? How Ray say can on immediately? You on your power supply also can on immediately, what? Correct or not? So why do you need a standby mode? Okay, Oscar. Correct, well done. Oscar, why you go and calculate so many answers? Ryan, you try again. Chelsea, are you there? Are you stuck? Okay, let me explain this question first. Okay, we all know that energy is power times time. And all of us, okay, by now you should know if you want it in kilowatt hour, your power must be in kilowatt, your time must be in hour. Is that clear? Okay, so your this power, you just multiply these two values. Okay, let me calculate myself. 230 times 0.034. I get 7.82 watt. If I convert it to kilowatt, I'll get 0.0782 kilowatt. Okay, time. How long is the time? Time is if we use one whole week. For example, one whole week. One whole week will be 7 times 24 will be 168 hours. Okay, so you multiply these two together, okay, you actually get 1.31376 kilowatt hour. Okay, in your working, you don't need to round off. Only the final answer you round off. So what is the cost? Cost will be energy multiplied by 25 cents. So can you do that? This multiplied by 25 cents. Okay, you will get 32.844 cents. Is that clear? Okay, but your question, because you are multiplying everything here, right? The smallest significant figure is this, 34. So you need to convert this to 33 cents, okay, to significant figure. Is that clear? Okay, this is based on the right answer where you use 168 hour instead of 138. Okay, we use 138, this amount will be lesser. Clear so far? Okay, so let me answer Yiting's question. So for example, your TV, you switch off. You want to on the TV, right? You must go all the way to the plug. Okay, that's the thing I told Howie just now. Right? Go all the way to your plug and you switch on your plug, then your TV got power. Am I right? But if your TV is on standby mode, there is some current in your TV that can activate certain sensor, maybe like the IR sensor. So you don't need to go to the plug and on it. You can use your remote control to on your TV. Is that clear? Understand? You think? Chelsea, are you there? I'm still waiting for you. You haven't tell me where you get the error. And for Chelsea, you don't use BP. If you are multiplying, you are using SF. Okay, Chelsea, are you there? Chelsea, you there? You understand? Okay, let's go to the next question. Can I erase everything? Can I erase everything? Okay, look at part C. Okay, start doing now. Okay, let me give you the data for. Let me give you the data for TV. Okay, TV is on 30 hour, standby 138 hour. And for the TV, this is 450 and 34. And this is 34. Okay, so everything in green is for the TV. Actually, don't need the data. Just explain will do. Okay, all explain. Come, let's explain. There's no need to calculate anything now. Okay, why unplugging the TV save more energy? Okay, Chelsea, well done. How about the rest of you? Okay, Yiting, your answer makes sense. For part 2, your answer makes sense. Okay, your part 1 is correct, Yiting, well done. I went to take a sweet. There's no new answer. Okay, Hao Rui. Okay, Hao Rui, your part 1 is correct, well done. Ryan, what's your answer? Bei Guan, what's your answer? Okay, that's the answer for part 1. Ryan, your answer is incorrect for part 1. Okay, Ryan, can you see my part 1 answer? Does that make sense to you? Okay, both of them use the same standby timing. Sorry, the standby current. Where is my pen? Where did I put my pen? Okay. So can you see? Both uses the same amount of current during standby. Okay, so since the TV uses on standby more hours, okay, therefore it makes sense to plug out the TV to save more energy. Okay, can all of you give me a disadvantage in completely unplugging a computer when not in use? Okay, one reason is it's more inconvenient as the computer is used for more hours per week. Okay, let me share with you Yiting's answer. Yiting's answer is computer takes more time to boot up. Okay, so unplugging a computer when not in use will take up more time. Does it make sense? Computer got battery man powering. I mean, not the battery that power the computer lah. But does the computer has a normal computer shouldn't have a big battery that power the computer. Okay, everybody okay? So let me move on to the next question. Okay, let's do this question. Okay, do 9A and B1. This is a 3-mark question. Oscar, you use the word unstable, which is not very good word. Okay, Ryan, try again. Good try, but try again. Okay, Oscar, that's a better word to use now. Well done. Okay, let me give you some example. Singapore has many high-rise buildings. Okay. What else? Singapore has a lack of land for wind turbine. Okay, you need a lot of land to build all these wind turbine. What else? Okay, the strength of wind is not constant, and okay, so the strength of wind not constant. So for it to be the main source of electricity will not be possible. You still need, okay, you still need an electric supply, power grid, a base power grid for it to work. Okay, if it's wind turbine as a supplement energy source is fine. Okay, but if it's for the main energy source, okay, there'll be problem because the wind is not constant and the wind energy cannot be stored. If there's no wind, then what happens to your electricity? Then the whole Singapore no power. Okay, so therefore, for it to be the main source of electricity in Singapore is not practical. Okay, do part 1, B part 1. Okay, Ryan, well done. Wei Kwan, well done. Oscar, well done. Okay, do part B part 1. Okay, I like Chelsea's answer very much. Later, I will copy and paste your answer and show everybody. Okay, Chelsea's answer is perfect. Well done. Oscar, your answer is also very good. Keep it up. Keep it up. How about the rest of you? Okay, describe part 1 to me quickly. Okay, how well done. Now, Ryan, Yiting, what's your answer? Ryan, Yiting, and Bei Kwan, what's your answer for B part 1? Okay, Yiting, well done, well done. Okay, let me share with you all Chelsea's answer. If I can copy. Okay, you all can admire the answer here. Okay, this is Chelsea's answer. Well done. And most of you can get the similar answer, so I think no problem. So 3 marks in your pocket. Well done. Okay, Bei Kwan, What is the word you use? Periportally. If you are using the word proportionally, then you will not get the mark. You will only give you 2 marks. Okay, let me explain to you. This is called direct proportion. Okay, which is y equal to kx. Meaning, straight line cutting through 0. Okay, if you have a straight line cutting through 0, you can say that the 2 variables are directly proportional. Is that clear? If you have a straight line but does not cut through 0, in this case, this does not cut through 0. They are linearly related. Are you clear about the two differences? Okay, linearly related, the formula is y equal to kx plus c or mx plus c. There is a plus c here. When there's a plus c here, it's no longer directly proportional. Okay, this is very important in your practical because they like to ask, what's the relationship between these two variables? Okay, so if it cuts through 0, you declare these two variables are directly proportional. But if they don't cut through 0 by a straight line, okay, after you plot the graph with a straight line, and if it does not cut through 0, they are no longer directly proportional, they are just linearly related. Okay, in your practical, if your best straight line is very near the 0, it means that your data is a little bit off. Okay, if it's a little bit off. So it's very, very near the 0, but never cut through 0, then you force the graph to the 0. Is that clear? Okay, but if you know that it's far, far from the 0, okay, then you don't say that the two variables are directly proportional. Okay, if I make myself clear, give me a yes reaction. Okay, this is important to all of you. Okay, Kwan, is it okay? Okay, let's go on. Now let's look at this. Okay, the wind speed is recorded in 1 minute interval like this. Okay, use this data, estimate the total energy produced in the 10-minute interval, and then give your answer in joule. Okay, do you all need the graph? Do you need the graph? Okay, you can see over here. When the speed is 0 to 5, the power is 0. Okay? When the speed is above 15, the power is 0.6 megawatt. Okay, if it's 10, what's the answer? If it's 10, it is 0.3. Can you see? If it's 10, it's 0.3. If it's 16, it doesn't matter. Okay, so this is all you need to know. The 3 value here. This is the speed and the power. Okay, let's look at the question now. Okay, so based on this data, can you find out what is the total energy produced in the 10-minute interval in joule. Okay, begin now. The explanation below, can you all see? This explanation is 1 mark. Okay, Ryan, well done. Okay, calculate quickly. Okay, Oscar, well done. Okay, Ryan, well done. Yeah, so next thing you'll do is this. You can put the power megawatt here. If the speed is less than 5, you know there's no power. If it's more than 10, or more than 15 is 0.6. If it's just 10, it's 0.3. So based on this, can you all do? Okay, Yiting, well done. Only Oscar and Ryan and Yiting. Okay, how about the rest? Pei Kwan, Hao Rei, and Xiao Xing. Okay, Yiting, your part 2 is correct. Well done. Okay, let me move on very quickly. The answer is this is what 1.8 times 10 to the power 8 joule. All right. Or you can also put 108 megajoule. Okay, but don't do that. They put here joule already. Okay, so 1.8 times 10 to the power 8 joule is the correct answer. Okay, why would this answer be an estimate? Why would it be an estimate? Okay, because we are assuming that the speed remains the same for the whole minute. Is that clear? However, in actual fact, the wind speed is not constant in the minute following the measurement. So the power output would not be constant, so affecting the amount of energy produced. Clear about this? Because we are assuming that, based on this answer, we are assuming that the first minute, the wind speed is constant at 2. Then for a second minute, the wind speed is constant at 3. Okay, so the wind speed is not constant in the minute, okay, following the measurement. So after you measure the next 1 minute, you did not even measure, and the amount and the wind speed may not be the same. So the power output, this value here, will not be constant. So when your power is not constant, your energy will not be constant. Clear? Okay, Oscar, can you rewrite it in another way? Okay, rewrite your answer in another way. Okay, let's continue. Okay, a wind turbine produces an alternating voltage of these. Okay, this one let me explain to you. What can you do? Okay, what can you do to reduce the amount of energy wasted? Okay, let me explain to you. One way you can do is use thicker wires. Okay, if you're not sure, use thicker wire. The reason is because the thicker the wire, the higher or lower the resistance. Okay, as thicker wires have a higher, has a greater cross area. Therefore, resistance is lower. So lower resistance will result in lesser energy loss as heat in the wire. Is that clear? Okay, the second method I haven't teach you yet, but do you remember last time I mentioned before, in a power line, in other country you use power line, correct? You see a lot of power line, and so on. Okay, so why do we, okay, in the power line, the further the distance, by right, the more energy you will lose. Okay, you will lose. So what can we do to minimize losses? Okay, so we have learned what is current. Current, the higher the current means that there's a lot of charges going through that point every second. Is that the correct definition? Q is it. So I is Q over T. Okay, it's the amount of charges passing through the point every second. So the higher the current, the greater amount of charges passing through. So when the current is very high, there'll be a lot of electron moving. So a lot of things that's moving, definitely over a long distance, you will lose a lot of energy. Clear so far? Next thing, you also learn that power is equal to VI, or energy is equal to VIT. So energy is lost when, so the electrical power that's supplied from one end to the other end will always have a constant power. Okay, let me erase this one. I repeat myself again. The power supplied from one end to the other end should have a constant power. So if you are able to increase the current, your V will drop. Likewise, if you are able to decrease the current, your V will increase to maintain the same power. So I mentioned earlier on, if your current is very high, you will lose more energy because a lot of charges are moving. So you're going to learn this later on. If I can make my current very low, very low, my energy loss will be minimal. Okay, so how to make my I very low? I need to make my voltage very high. Okay, very high. So we're going to use one equipment that you haven't learned yet, is use a transformer. Okay, use a transformer to step up the voltage. Okay, to a very high voltage. Okay, in the cable, in the transmission cable. Is that clear? So once you reach your house, then you use another transformer to step down the voltage. So at home, your voltage is 230 volt. But during this transmission, okay, it could be like 50,000 volt. Okay, so why do I make my voltage of this wire very high? Because if I make my V very high, my current will be very low to maintain the same amount of power passing through the cable. Is that clear? So when your current is low, the energy loss will be lesser. Okay? Okay, so what happens if I do that? Let me write down. Okay, so I use a transformer to step up the voltage in the cable. Okay, so the current will be reduced. Okay, thus minimizing energy wasted in the cable. You're clear? Okay, when your I is low and you will actually reduce energy that is wasted. Any question for me about this? You're clear about this? So transformer is something that you can use to step up or step down the voltage. So when you step up the voltage to maintain the same power, your current will drop. So when your current is very low, it means that not much charges is moving through the wire. Am I right? So not much charges moving through the wire, the energy loss will also be lesser. Ken? Are you clear about this? Does it make sense? If it makes sense, give me a yes reaction. Okay, next question. Well, there's a lot of questions I want to go through today, but I only managed to go through about half. So that's not a very good progress. But never mind, let's continue. Next week, I'll go through a new topic. But this topic, do you realize that the questions are all similar one? There's nothing much you can do to all these questions. Okay, 2016, 11 either. Okay, let's skip all these things. Y'all can read yourself. Let's do part B. Okay, do part B, just do number 1. Everybody do that now. Okay, 1 and 2. All of you do that now. Do part B, 1 and 2. Okay, all we do B part 1 and 2. Okay, Oscar, your 1 is correct. Well done. Ryan, is your answer 2 accurate? Harry, well done. Ryan, you put a 0 there means it's still too accurate. Your answer is wrong. Okay, Oscar. Oscar. Hold on for a while, Oscar. Okay, let me give you a common fuse rating that you will see in Singapore. You got 1A, 2A, 3A, 5A, 10A, 13A. So these are the more common fuse rating. Okay, so based on this value that I written here, what would be the best fuse to use? Okay, Oscar, well done. Ryan, well done. Ryan, your answer is correct now. Oscar, your answer is better now. Howrey, well done. Oscar, well done. Yuting, well done. Xiao Xing, your A answer is correct. Very good. Okay, very, very good. Okay, so for part 1, I will not go through with you. Most of you are able to do it. You'll get 2.5A. Remember to write down 2SF. Okay, so the rating here should be slightly more than this. If you look at this, 2 will be too low. Okay, the best one will be 3 ampere. So the 3 ampere will be a good fuse to use to protect this house. Let's continue. Okay, now calculate the maximum resistance of this section of the mains cable. Okay, just do this one. These two don't do. Okay, let's do this one. Everybody do that now. Okay, 2 mark question. Can you find the maximum resistance? Okay, Ryan, well done. Yiting, very good. Hao Rui, very good. Oscar, very good. Okay, Hao Rui and Oscar, can you write down the 2SF at the end? Okay, what formula do you use for this? You all know that power is VI, but you're given only the I and the power. You want to find the resistance. Okay, so you don't have the V. You know that V is equal to RI, right? Okay, you don't know the you don't have the V, you know that V is equal to I, so use the formula RI square in this question. So you know, okay, you know your P. Okay, you know your P, you know your I. Can you find the resistance? Okay, from here you should be able to do your resistance will be 0.0012 ohm to 2 significant figure. Clear? Can? Do you want to do one more question? Okay, let's end the lesson today. Is that okay? You want the lesson end? Give me thumbs up. If you want one more question, give me a clap. Ryan, why give me the face? Okay, so I will see you next week. We'll start the new topic on magnetism. Any question for me, you all can stay back. Okay, if not, you may leave. Okay, thank you so much. Good night. See you next week.